Kia ora. Differentiation of the exponential function. So the exponential function can be written as y equals e to the power of x, or the exponential of x. And previously we've been using this function by using our shift, our len button here, and you can find that on your own calculator. So what does the curve look like? So what we've discovered is if we plug in different x values into the equation, what we get is we get a nice smooth curve that grows exponentially. What we're trying to do now is to focus on what would the equation look like if we were to differentiate it. Interestingly, the exponential curve can actually be written as a series. If we differentiate each of the terms in those series, then let's have a look and see what we get. So if we were to differentiate 1, we'd get 0. If we differentiate x over 1 factorial, so that just means it's 1, we're going to get 1. If we differentiate x squared over 2 factorial, which 2 factorial just means 2 times 1, we're going to get 2x over 2 times 1 factorial, which will just be 2. If we differentiate 3 cubed over 3 factorial, we're going to get ourselves 3x squared over 3 times 2 factorial. If we differentiate x to the power of 4 over 4 factorial, 4x cubed over 4 times 3 factorial, and so on. If you have a look at this, what we can see by simplifying is that in fact the series is identical. So what this actually shows is that the derivative of the exponential function is in fact the exponential function. Or in other words, the infinite series does not change when it is differentiated. You'll find this written in your formula sheet. If the equation is a bit more complicated and it's not just to the power of x, so it's something more complicated, some sort of function, then what we'll find there is that we apply the chain rule that we've learnt previously, or the cover-up rule, like I've explained it. So what we've got there is e to the power of a function. So then what you're going to do is just differentiate that function, put it out the front, so it's f dashed of x times by e to the power of f of x. So it's that simple. Here's our first example. Differentiate 7e to the power of negative 5x. So from what we've just learnt there, all we need to do is to differentiate that power term and put it out the front. So we've got negative 5 times 7e to the power of negative 5x. So that's going to give us negative 35e to the power of negative 5x. And I've just got there, note, there's no change to the actual exponential function. Second example. Differentiate 2e to the power of 3x squared minus 4. So looking at the power, what we need to do first of all is just to differentiate that and put it out the front. So differentiating, we'd get ourselves 6x to the power of 1, and then all we do is we write down that whole function, including that 2 there obviously, and then we're just simplifying. So that would end up giving us 12x times e to the power of 3x squared minus 4. Again, noting that that exponential function looks the same. All right, give these a go yourself on page 268, exercise 15.03. Good luck.